Hi, Mr. Garb here with our third section of conics. Now we studied two sections of circles. One where they're in the regular form and one when they're not in the standard form. And so ellipses you'll see have a relationship to circles. I mean they're not cut directly across, so you have one side's a bit longer than the other. It's like an oval. That's what you want to notice. So ellipse, the actual mathematical definition of ellipse is kind of set of points, so it's this oval shape here, set of points such that the sum from any point on the ellipse, any point on the ellipse to two different fixed points. These two different fixed points are called foci. So if you take a point like anywhere on the edge, and you go from here to here and here to here, that distance adds together will be the same no matter where I move. So if I move to here and I look at these two distances, they'll be the same also. So these two different distances, d1 and d2, their sum is the same no matter where I move on the outside of the ellipse. So that set of points along the outside, so that those distances, or their sum is the same, is called an ellipse. So those two fixed points, okay, are called foci, the plural of two focuses, a focus. And d1 and d2 remains constant, d1 plus d2. So those are those two distances from the foci to a given point on the outside of the ellipse. Will be the same no matter where we move. Okay. So if I move over here, then I'll have this distance and that sum will be the same as this sum. So it'll be the same either way. So that's a very special relationship. So we're going to have a major axis, the longer axis of symmetry. Okay, so we're going to talk about what they are in a second. So basically, I'm going to have a longer side to my oval and a shorter side to my oval, and they're going to have special names. So the major axis is called, that's the longer axis of symmetry, and that's this one here. Longer axis of symmetry is called the major axis, and the shorter one's called the minor axis. So the minor axis is the shorter axis of symmetry, and the center, that's the point at which the major and minor axis come together. It's like the center of the circle. It's going to be the center of the ellipse. So the center is the point where the minor and major axis intersect. The vertices, okay, the vertices are kind of like the endpoints, right? That's where the ellipse hits the axis there. So the vertices are the end points of the major axis. Okay, so the vertices are the major axis where they hit here. Major axis. And the co-vertices are the minor axis. So these are also vertices, but they're called co-vertices because they are from the minor axis. So the end points of the minor axis. So major axis longer, minor axis shorter. Endpoints are called vertices or co-vertices for shorter one. All right. So therefore, that's the focus. That's the focus. This is the co-vertex. Co-vertex. That's the vertex. And that's the vertex. Alright, so this is my horizontal. So horizontal ellipse is longer horizontally, and a vertical ellipse is longer vertically, where the major axis is vertical or the minor axis is horizontal here. So let's label this guy. So this is going to be my vertex here, and that's my vertex here. This is our co-vertex here, and our co-vertex here. That's our center. I forgot to put that last time, so I'll label this one. That's our center. And that's our focus. Remember, focus is the two fixed points where the distance is calculated from to the outside of the ellipse. Alright, so the vertices or a units away from the center. So vertices, so in this case, vertex, vertex, that's a. So a would be this distance from here to here. Okay. A units away from the center, so here's a. So a to the, that's going to be a here, and this is going to be a here. Okay, so a is the vertices. And the co-vertices are plus or minus b units away. So b is going to be the shorter distance. B is going to be the shorter distance from the center to the co-vertex. Okay, so the major axis is going to be the length of the major axis is 2a, a to here, and then a to here. So this is going to be 2a, and the minor axis, obviously. So this will be a, this will be a, this will be b, and this will be b. So the length of the minor axis is going to be 2b. The foci are plus or minus c units from the center. Okay, so c units. So from here to here, and from here to here, that's c. So c is going to be here, and c is going to be here. So they are plus or minus c units away from the center. And so the formula for finding c, it's not Pythagorean theorem, it looks like it, but c squared, so it looks like Pythagorean theorem, but it's not, is equal to a squared minus b squared. So the length, okay, so the length from the center to the for the vertex squared minus the co-vertex squared, the length from the center to the vertex squared. Those, when you subtract those two, that gives you the distance to the focus to the center squared. It looks like Pythagorean theorem, but it isn't. But here's the standard form for an ellipse with center 0, 0. Okay, if the center is 0, 0, you're going to have x squared over a squared. Remember what a is. A is the distance from the center to the vertex. And b is the distance from the center to the co-vertex. Now this is a special standard form when the center is 0, 0. If the center is not 0, 0, then we have to subtract something after x, or we have to subtract something after y. Alright, so if the center is at hk, let's say the center is not at 0, 0, let's say it's 2, 3 or whatever, then you're going to say, okay, well, it's just going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So these are only different because I'm putting in h and k and they're not 0, 0 here. Now, we're going to flip-flop this guy. And since so this goes with horizontal, this is a horizontal ellipse where the x distance is longer. Now I want to switch this guy when it's a vertical ellipse. I'm switching my a squared and b squared, so it's going to be x squared over b squared, okay? Because b is my horizontal distance here. Okay, a is my vertical distance now, so that's why we have to switch that. Okay? So the x squared and the y squared is not going to change. But the b squared and the a squared do, because this b represents this horizontal distance in this case. Alright, so this is going to be a squared equals 1. So when I have a center that's not 0, 0, that'll simply be x minus h squared over b squared plus y minus k squared over a squared equals 1. So just remember that these a squared and b squared are going to switch because this is the horizontal distance and this is the vertical distance in this case. Alright? And 1, yes. That's the standard form. We always want to make that equal to 1. Alright, so now we're going to graph some of these ellipses, and these are the steps right here that tell you what to do, a little checklist for you. So you're going to write it in standard form. So we have the ellipse in standard form, check. Now we're going to graph the center HK. Well, in this case, H and K is 0, 0, so we know we could put the center is going to be at 0, 0 right there. Alright? Now we're going to graph, so the center is going to be 0, 0. Now the vertices, graph the vertices using the larger denominator. So yeah, so the larger denominator is going to be here, so that's going to be 6 and negative 6. So that means it's going to be a vertical asymptote. You see how the larger distance is here, so that means that's going to be a vertical one because it goes with the y. So the vertices are going to be 0 and plus or minus 6. So that means 0, 6, 0, negative 6. It's going to be one that goes up and down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we know it's going to be a vertical ellipse, and it's because we have that b squared is equal to 4 and a squared is equal to, a is always the larger distance, just so you know, with the a and b business. So a is always the larger one, and b is always the smaller one. So b squared equals 4 and a squared equals 6. Okay, 36. So we know that b equals 2 and a equals 6. Now in order to find c squared is equal to a squared minus b squared. So we know that c squared is equal to 36 minus 4, so c squared equals 32. So c equals plus or minus 32, which is about 5.6 repeating. So that's our c, which is the distance to the foci. Okay, so the covertices are going to be 2, obviously. 2 and negative 2, because b is 2 and negative 2, so our covertices are negative 2, 0, and 2, 0. And the foci, we just found out that we're c at 6 and, are going to be 0, comma, 5.6 repeating, and 0, comma, negative 5.6 repeating. That's the foci. So that foci is going to be the distance from the center towards that major axis towards A. So it's going to be like right around here. So, okay. So we can draw that ellipse. So the foci are going to be just shy, right there, of the vertices. Okay, now this one down here, we have x squared. Okay, so in this case, a squared equals 64. Remember, a is always the larger of the two. B squared is equal to 25. So therefore, a is equal to 8, and b is equal to 5. And we could say that the center is going to be 0, 0 again, because we're not subtracting h and k here, so the center is going to be 0, 0. We know that. We know that a, in this case, it's going to be a horizontal ellipse because it's wider, because the squared number underneath x is larger, so it's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then this one's going to be 5 vertically. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's going to be kind of oblong. It's an ellipse. So my vertices are the longer ones, so that's going to go from negative 8, 0 to 8, 0. My covertices, okay, covertices are going up to 5. Yep, so it's going to be negative 5, 0. Oh, no. It's going to be 0, negative 5. And 0, positive 5. And what's my c squared? My foci, right? So they're going to be out here. So c squared is equal to a squared minus b squared. And again, a has to be larger, so c squared is going to equal to 64 minus 25. So c squared is equal to 39. So c equals the square root of 39. So that's about a little over 6, so 6.24. So therefore, it's going to be negative 6.249. You know it has to be in the x-coordinate because that's the wider one. So it would, the foci number, c, whatever, would be go along with the larger x distance. Okay, it's negative 6, comma 0, and 6.24, comma 0. So our foci would be like right around there and right around there. Those would be our foci. So remember, the foci are the distance from, like, say, here to here, plus here to here is the same. So this D1 and D2, these two distances are the same no matter where I move. So if I move over here from these two foci. I'll continue with the rest in the next part of the video.